you'll get y equals 0.35x times 91.5. Suppose this kind of equation you will get. So this is the value of A and this is the value of B. You need this number. This is for one device, rotometer. The similar thing for vortex shedding meter, turbine flow meter will be same. We'll put vortex shedding meter here. So in second graph, your x-axis will be vortex shedding meter. Okay. Now, normally for a calibrated device, the equation is for linear fit. The equation is x plus b. But as we need to calibrate some devices, so our final equation will be this one: ax plus b plus or minus some additional terms. So here delta A times x plus delta b and delta standard. Delta standard is the uncertainty of the standard device, which is turbine flow meter, which is given in the manual. Delta A is called scale uncertainty, delta B offset uncertainty. We have some equations for this too. This is the equation for delta A, this is the equation for delta B. Now,
What did you call delta A?
delta A scale uncertainty and delta B offset uncertainty. So now in these equations, if you want to calculate, we need SYX value, we need SXX value, we need T alpha by 2 V value. These three value, if we get these three value and some value from that table, we can calculate everything. Now, for delta XX, there is an equation. XI, X bar. We need only two information. The mean is X bar. And these are individual XI. Then SYX, we need YI, individual YI from the left column. We need N is number of data. We took 11 data today. So N is 11. FCal XI, this one. How can I get it? So from this plot, we get the equation y equals ax plus b. So for each individual xi, for example, for the first one is 4.3. If I put 4.3 here, we'll know a and b. Then we'll get some value of y. This is our FCal xi. So you'll put each individual xi into this equation, and the value of y will be your FCal xi. This is the crucial part of this calculation. Now we know these things, so we just only need to know this term, T alpha by 2p. So it's given like a 95% confidence interval. I don't know what it is actually. So for that, alpha by 2 value is, if you calculate, it's 0.025, and we need the value of v, which is n minus 1, number of data minus 1, which is 10. So for these two number from table B3, there is another distribution table. From this table, for the value of v and t alpha by 2, you will get the value of the whole term. So now I think you know everything. Put in the equations. First find out SXX, then SYX, then delta A, delta B. And then this is your final answer. So you'll have two final answer, one for rotometer, one for vortex shedding meter. Same calculation for two devices, and I want you guys to show both calculations in details. Not only one calculation, everything, and then tablet show in the table all the values, and the way I showed you, told you to create the first table, do it like that.